Leaving the only home you've ever known requires sitting on top of millions of pounds of explosive thrust, a journey that eventually ends by slamming back into the Earth's atmosphere at 25,000 miles per hour. Before we take that ride, make sure to subscribe, hit the like button, and share this video with your favorite stargazing friend. For centuries, our relationship with the cosmos was defined by looking up. We set up telescopes in our backyards to peer into the dark, marveling at the massive, swirling storms of planets like Jupiter. Eventually, we began launching those same lenses into the void, specifically so we could turn them around and look back at ourselves. Reaching a distant star is an achievement of physics, but seeing our own home from the outside for the very first time offers a perspective that cannot be found on the ground. To get that perspective today, we rely on the SLS, a towering assembly of fuel and metal that generates the millions of pounds of thrust required to physically tear a vehicle away from Earth's gravity. That rocket carries the Orion crew capsule, a vehicle designed to take a new generation of astronauts into a deep orbit around the moon. From that vantage point, the crew will witness Earth rising over the barren, gray craters of the lunar horizon, a bright blue marble framed by an alien landscape. Returning home means hitting the atmosphere at Mach 32. The friction creates a pocket of plasma around the spacecraft, pushing external temperatures to nearly 5,000 degrees Fahrenheit. Down on the ground, teams in mission control monitor every second of the descent. They are the human element responsible for ensuring the capsule's heat shield and parachutes perform exactly as designed. The Artemis mission demonstrates that the return trip is as vital as the launch. It transforms Earth from a starting line into an isolated, fragile destination. If you push out further to the red, desolate surface of Mars, the visual dominance of our planet vanishes. Look up into the Martian night, and Earth is no longer a world of oceans and continents. It is reduced to a bright, distant star. Even during a solar eclipse on Mars, when the moons pass directly overhead, Earth remains a tiny, unremarkable speck in the background. From this distance, every person who has ever lived and every single event in human history is contained within a single point of light, lost among the stars of a foreign sky. Travel deeper still, past the gas giants, to the frozen moons of the outer solar system. Here, the environment is so extreme that moons like Enceladus spray jets of water vapor through cracks in their icy shells. Voyager 1 traveled through this entire region and kept going, eventually reaching a distance of billions of miles from Earth. Communicating across that much empty space creates a massive delay. Even at the speed of light, a radio signal takes hours to reach the probe. It was from this lonely position that astronomer Carl Sagan convinced NASA to turn Voyager's camera backward for one final look at the inner solar system. On Valentine's Day, 36 years ago, that aging probe captured the pale blue dot, an image taken from the very edge of our solar neighborhood. If you want to keep exploring these milestones with us, subscribe to join the journey. That single image shows our world as a tiny speck of dust suspended in a sunbeam, illustrating our ultimate cosmic vulnerability. When we pull our perspective back from the dark outer solar system, flying past gas giants, we return to the vibrant blue of Earth. We see it in the final moments of the Artemis journey, as the capsule clears the fire of re-entry to splash down safely in the ocean. Astronauts call this the overview effect, the realization that from the outside, geopolitical boundaries disappear, replaced by the sight of a single shared atmosphere. Whether we use a backyard telescope or a multi-billion-dollar NASA mission, the gift of space exploration is the humility it forces upon us to protect our home. Thanks for watching, and keep looking up.